When I was like 17, I went to jQuery Conf in Boston, and I'm a total noob programmer. I asked Yehuda Katz if Ruby was an object-oriented language, and he just laughed at me.
I don't blame him.
I was bullied, dude. Bullied on the spot.
This episode is sponsored by Front End Masters. They have a terrific lineup of live courses you can attend either online or in person. Their upcoming course is Hardcore Functional Programming in JavaScript with Brian Lonsdorf. You can also get recordings of their previous courses like JavaScript The Good Parts, AngularJS, CSS3 In Depth, and Responsive Web Design. Get it all at frontendmasters.com. This episode is sponsored by Watch Me Code. Have you been looking for regular, high-quality video screencasts on building JavaScript done by someone who really understands JavaScript? Derek Bailey's videos cover many of the topics we talk about on JavaScript Jabber and are up on the latest tools and tricks you need to write great JavaScript. He also covers language fundamentals, so there's plenty for everybody. Looking over the catalog, I got really excited, and I can't wait to watch them all. Go check them out at javascriptjabber.com/watchmecode. This episode is sponsored by Component One, makers of Widgmo. If you need stunning UI elements or awesome graphs and charts, then go to widgmo.com and check them out. Hey everybody, and welcome to episode 107 of the JavaScript Jabber Show. This week on our panel we have AJ O'Neill.
Yo, yo, yo. Coming at you live from Provo.
Jameson Dance.
Hi, friends.
Merritt Christensen.
Hey, guys.
I'm Charles Max Wood from devchat.tv, and this week we have a special guest, David Nolen.
Hi. How's it going?
Do you want to introduce yourself really quickly?
Yeah, so I'm David Nolen, one of the lead developers on the ClojureScript project. I also created the sort of Om library, which is a sort of lightweight library over Facebook's React that sort of takes advantage of immutability. I was recently employed at the New York Times. I was there for 4 years, and now I've joined up with a company called Cognitect. They're sort of the stewards of Clojure as well as a new database that's immutable called Datomic.
You just answered all the questions I was going to ask.
Oh.
All right, let's do the picks.
Oh, cool. No, did you move to Cognitect to work specifically on ClojureScript?
Not specifically, but that's definitely one of the perks of working for Cognitect, in that, for me, ClojureScript was just sort of like a labor of love and something that was just kind of fun that I did on the side. And it was kind of exciting to see the community around it sort of take off. And then, Cognitect sort of approached me and they said there were some projects they wanted me to work on. And, I'd also be able to do spend some work time maintaining ClojureScript. That was definitely an attractive aspect of joining forces with them.
Sure. Were you using ClojureScript at the New York Times before, or was it more of a hobby thing?
There wasn't any ClojureScript at the New York Times. My past team was called Interactive News, and our stack was primarily Rails and quite a bit of JavaScript on the front end. But yeah, it was mostly Rails and JavaScript.
So I would love to, for a lot of people, what is ClojureScript?
It's an implementation of Clojure, which was first created for the JVM. The JVM implementation is now, I think, coming up on 7 years, if it's not already 7 years old. ClojureScript is now 3 years old. It's finally getting to the point where it's pretty mature. There's still some things I think we need to see fixed before we, bless it as being 1.0. But it's come a long way.
Doesn't Clojure run on the JVM?
Clojure runs on the JVM, yes. Clojure actually compiles to JVM bytecode, which is pretty cool, and it's pretty fast for a dynamic language. ClojureScript, it's a source-to-source compiler. So ClojureScript takes only a slightly different version of Clojure and compiles it directly to JavaScript. Very much in the same vein as CoffeeScript or the other transpilers that are out there.
Mm-hmm.
It provides a whole standard library along with that, though, right? It's not just a kind of a syntax translation.
Yes. So some people get confused. So there is no runtime, right? So there's no runtime support or any weird thing that we do. We really do just emit JavaScript data structures and JavaScript functions. And that works because Clojure is basically more or less oriented around functions. We generate JavaScript objects because a lot of the data structures need to be fast, and JavaScript objects are now pretty heavily optimized. But yes, we do ship a large standard library.
Why would somebody use Clojure over, raw JavaScript or, ClojureScript to be precise, but over JavaScript or CoffeeScript or TypeScript, etc.?
So ClojureScript is probably more different than TypeScript or even Dart and CoffeeScript are from each other. Like those languages, for the most part, are like, class-oriented. They don't actually, the semantics aren't that different. They're very much like object-oriented, imperative. So programmers really like them because, they're well-designed and they're very familiar. Clojure is a little bit more radical in that it's oriented around immutability, and that's not something you see very much in those other languages. We can dive into why immutability is cool, but that's really the big difference.
Let's go there then. Why is immutability cool?
So immutability is kind of neat. So something that JavaScript programmers, I think, sort of do all the time, like a lot of code you do object extend, right? That's like really common. You have some object and you want to add some properties. Generally what you have to do, if you get something from somebody else, you have to be, I have to clone this thing because I got this from somebody else. So worrying about aliasing or mutating somebody else's code or having to defensively clone something, that's something that ClojureScript programmers don't do. And once you sort of get that, there are a lot of types of programs you might write kind of get dramatically simpler because it's just not something you're concerned about. So if I would say anything, like ClojureScript tries to deliver the convenience, at least at the sort of linguistic level that JavaScript offers, but it tries to replace all the places where JavaScript is sort of like fast and loose about mutation. It tries to add a little bit more discipline to that.
When it compiles, it just ignores the parts that implement mutability and things that we have on regular JavaScript objects.
That's not true. So the other thing is that ClojureScript's really pragmatic. Of course, there are lots of types of programs one might write where you just need to be high performance. And in fact, our immutable data structures, the reason they're so fast is because under the hood, we do use mutation. That's why they're so fast. We do lots of crazy tricks around cloning arrays and sharing structure between different immutable values as much as possible and only mutating the part that's changing. So we expose those facilities to users because there are programs where you might care, where you need it. And also, it's actually super important for interop, right? If I want to talk to the canvas tag, I have to set properties on the canvas tag. So I need access to mutation. But the idea is that when you're writing a big program, the places where you use mutation, it's quite small. Whereas in a typical JavaScript program, mutation's happening everywhere.
So I feel like that's a really concise definition of immutability, but I don't think we've talked enough about how much that's a pretty huge paradigm shift from the way that most people program most of the time in the browser. Can you talk about maybe the effects of that? So we've talked about what it is. How does that change the way you write programs?
Well, I definitely think that when you write programs that are less stateful, I think people kind of know this, like people like stateless services, right? People understand that's important. So if your program is if you think of your JavaScript program as if I start designing my JavaScript program as a series of stateless services, then it's easier to reason about, right? It's easier to test. There's the way that components interact or different parts of your program interact, there's less variables at play. So that's the reason people got excited about Clojure. And then when ClojureScript came out, people got excited about the fact that I can have an easier to reason about program and target these amazing JavaScript clients, like the browser and Node.js and so on.
Sure. It seems like the programming paradigm of mutability and imperative code is so ingrained that these platforms are kind of embracing them wholesale. Like things like Object Observe is around state change monitoring and things like that. Do you feel like that's, a mistake? Are there things that you would like to see the browser platform implement? I would imagine that you would think that two-way data binding and some of these things are just the wrong way to think about these problems because they all end up in these really stateful sort of situations.
So, everybody has their opinions about these things. I've been a professional JavaScript developer for 8 years now, and I've built some fairly large projects that were done in an object-oriented style, and I actually thought they were pretty good. And when I look back, I read that code and understand it. But at the same time, there's a sneaking suspicion that there's something better or faster or more efficient or more expressive than, lots of mutable objects and observers everywhere, right? That's I think everybody understands with some discipline you can make that work, but I think maybe we'll touch on that a bit. I think React kind of showed that there are other ways to approach the kinds of sort of software problems people are attacking.
Do you want to talk a little bit more about React and Om? Because I'd say that's one of the things you've been most well known for recently, at least.
I think it's kind of funny because in a sense, you were sort of, the great revivalist for React, right? People didn't really get it until you started really talking about its use case.
Yeah, so it was funny. I actually, when I first saw React, my response was pretty much the same as everybody else's. I was like, don't stick HTML in my JavaScript.
One of those angle brackets.
Yeah, I totally wrote it off. I was like, this is not something I'm ever going to use. But I have a good friend, Brandon Bloom, who worked at Microsoft, and he'd done some stuff on Xbox, and he was sort of familiar with sort of programming games on the Xbox. When React came out, he was like, yeah, it looks weird, but you really should look at how it works, because it's kind of like the way that game developers do game engines. And, I sort of ignored it, but then Pete Hunt went to JSConf in 2013, and he gave a great talk about the design. How does it actually work? It wasn't just a sales pitch about like how this solves all your problems. It really sort of explained the architecture behind it. Mm-hmm. And I, it sort of had an epiphany, was like, because React is based on diffing and it's not based on observation, I really saw an opportunity for immutable data structures to basically make React's diffing process much faster. Because of immutable data, the diffing algorithm just has to do less work. And that was just a hunch, right? I didn't yet have evidence. And Om sort of was like an experiment to see, just for fun, I'm going to see if this is any faster. And then it was sort of shocking how much faster it was. And not only just how much faster, that I didn't really have to do that much work. And it was just way more efficient than the types of, I would say, like when you first set out to write a JavaScript program, like people say optimization is the root of all evil. And that's true, because you're going to get sidetracked when you're like optimizing. But often when you write a JavaScript program, you're just doing the naive way, and then it performs really, really badly, right? And what was fun about React and Om was that it was really naive. I didn't spend that much time optimizing it. And, it was cool to see that it was just, without much work on my part, significantly faster.
So I know you've covered it in detail in other places. There's a podcast you did with the Thoughtbot people where you talked a lot about kind of the internals and how specifically ClojureScript and Om make React faster. But do you want to give a quick explanation of it?
Yes. So the way that React works, actually the React guys have done a great job in making it fast. But basically React takes, if you look at React, it basically takes JavaScript objects as parameters, right? And in order to do the diffing, what they have to do is they have to traverse whatever value you give them, because there's no efficient way to know that something has been mutated. Unless, of course, you can do something similar to this with observation, right? And we'll get back to why observation doesn't give you all the properties that you want. But without explicit observation that works on all JavaScript objects you might be interested in, you have to just walk the entire JavaScript object to figure out what changed between these two frames. And with immutable data structures, you don't have to do this. And this is just simply because if two immutable values don't change, they're going to basically point at the same thing in memory. That's really the key idea here. Whereas in JavaScript, you can't detect it. In ClojureScript, you can, because if something is different, you know it's different. If something is the same, you don't need to look at it. This is just based on pointers, right? In JavaScript, if you point to some location in memory and somebody changes something about that thing in memory, the pointer doesn't tell you that it's different, right? Does that make sense?
Mm-hmm. Sure. Mm-hmm.
But in ClojureScript, if the pointers change in memory, it can't possibly be the same thing, so you know to check. But if the pointers are the same, you do not need to look at the contents of the thing that's being pointed at.
So maybe another higher level way to say it is that in ClojureScript, equality is based on the values that are in an object, not where it points to in memory. If two objects are equal in ClojureScript, it means they contain the same values. So you don't have to descend down into them to check if their sub-properties are equal or not, right?
That's exactly correct. It's impossible to change something nested inside of a value and not break the pointer. That's exactly right. If you try to update something in the deeply nested in the thing, you're going to change all the pointers. All the pointers must change.
So it seems like this would become a memory problem really quickly, right?
Yeah, that's what I was thinking.
But I know that FRP people have interesting strategies for abstracting these things with deltas and stuff. How does ClojureScript store these kinds of data structures?
The idea is very, very simple. You want to represent an array. But instead of having the array be represented as one huge array, which of course is impossible to update efficiently in a mutable way, you can instead organize your array-like thing in terms of trees of arrays. You would have an array at the root that, say, it has 4 slots. And so if you want to get to the first thing, you descend down the first slot to the next array that has 4 slots in it. And then you got to descend again And of course, this sounds like, oh, that works. And it turns out if you just pick a sort of like a really good branching factor, it's pretty wild what you can do. So in the branching factor in ClojureScript is 32, right? And say you have to descend 32 of these arrays, like you go to depth 7, right? If your branching factor is 32, that's 34 billion items, which I think is like, you're talking like, I don't know, 60 or 70 gigs of RAM, right?
Yeah.
That's pretty wild. So you only have to hop down 7 arrays to get to the thing you want. And, you know, that size is far bigger than anything you're going to want to put in the browser. And so what's really cool is that imagine you want to update something that has 32 billion items in it, right? How many things you have to update one value? You just have to replace 7 arrays, right? That's pretty crazy. In order to update any value in something that large, you're only going to have to pay for 7 array updates. And as it turns out, JavaScript is now, for arrays that are small like this, cloning is really, really, really fast. If you do an array prototype slice on an array like this, it's a very cheap operation.
So you said that ClojureScript compiles to these kind of plain old JavaScript data structures.
Yeah.
Do you guys compile to like an abstraction for making this kind of simpler to pull stuff out of? Maybe an abstraction that people could use outside of ClojureScript? Or is it pretty coupled to the ClojureScript compilation output?
So I maintain a separate library only for Node because the payload's a bit too big for web, sort of like web clients. But what we did was we exported like 60% of the ClojureScript standard library to Node.js. So if you want to use and you want to play around with these data structures, we have a pretty nice API. It's called Mori. I think we're at version 0.2.6. People use it in production. People are pretty happy with it because you get a lot of the value from ClojureScript without having to use ClojureScript directly. I actually got a really nice email from one of the Meteor.js devs, and I think they're about to release a dependency resolution, like package management thing, that uses Mori under the hood, which is pretty awesome.
That's way cool.
That's really cool. So basically the reason that you can efficiently work with immutable data structures is because it doesn't copy the entire object. It just copies the smallest chunk it needs to when you change something, right?
You only need to copy the path that changed. That's exactly right.
Okay. I'm not an expert by any means with functional programming. I messed around with trying to do it all by myself in just regular JavaScript, and I ended up doing just object cloning everywhere. So it was kind of messy because it had these extra chunks of code in every single function call, and it wasn't super fast because I was cloning these fairly large objects and stuff.
Bro, I've been a perpetrator of the chaining underscore methods and calling it FRP, you know?
Yeah.
Did you guys see this sweet .bind I did with this sweet partial application?
Yeah, that was just a big pain point for me because it felt like I was working against the language. It felt like I was trying to do something that wasn't made easy by the language at all.
Yeah, so, I mean, again, people like Mori, right? We tried our best to make it, like, palatable to JavaScript developers. We try to make it as easy as possible, but it is true that ClojureScript can produce better code. Like, ClojureScript will often produce code you would never want to write by hand, and stuff that we've benchmarked on V8 and JavaScript Core and SpiderMonkey, and we can do these patterns that, like, you would never want to do. Like, for example, all of our fastest data structures use this 32 array branching factor trick. We have a really, really fast hash map. But in order for the hash map to be fast, you have to, on some JavaScript engines, actually emit a JavaScript literal with 32 nulls in it in order to guarantee that you get a dense array.
Huh.
That's something that nobody would ever write by hand, but we can generate that for you.
Sure. One of my big questions is, I've definitely been in the world of sort of state, and I think that world has proliferated even worse when you start to use things like, you know, the whole backbone, Ember, Angular sort of mantra. You get into these really stateful situations where you fired a bunch of observers and you're not sure where in the chain your data's changed, etc. And it certainly leaves you wanting for a simpler model because things become quite untractable. And what I'm wondering is, do you believe this is, I mean, obviously you care enough about it that you're working on it, but do you believe this is a better way of building web apps? And if it is, how can people learn? Because it's obviously a paradigm shift for most people from the web world to go from this C syntax looking language to the Lisp parenthesis, you know, kind of overwhelming look.
I really recommend, like, I'm a big fan of when there's something interesting or new that's very different. Like, like that's kind of why I made Mori, was that, like, to make immutable data structures less scary. Check it out, play around with it, see what you think. I actually have some friends at a startup right now, and they couldn't convince their team to build their next thing in ClojureScript, but they decided, hey, we're going to do it in CoffeeScript and Mori and React, and they're really loving it, and they're having a great time. That team is figuring out, how to build apps in this way, again, without like completely getting into how ClojureScript works. I definitely think, a lot of these ideas can be adopted without leaving the comfort of your home, right?
Sure.
But as far as to whether it's the solution, I mean, I'm always like, I made Om, and like you put something out there and people are starting to do really cool things, like things that I'm like, yeah, that would have been a really big pain in the butt to do in JavaScript. And it was like, took somebody like, they wrote a tiny bit of code and they have something pretty awesome. What's something that's really cool? Have you guys seen Goya at all? This thing Goya, it's like a pixel editor.
Yeah, that thing's a ton of fun. And it has undo, like, cooked in, right? Because of the immutability stuff.
Yeah. So it's awesome. So it's a 64 by 64 pixel editor. And he represents each frame, like the entire pixel region, as an immutable vector. And it's awesome. He had to write like 50 lines of code to get like basically undo. There's no code to do the undo. He gets undo for free, but it also made you can generate an animated GIF from the app states that he's saved. And
sold me.
Yeah, it's really cool. And again, what's awesome is that like there's a lot of code there in his project around the interaction, but the code for the undo and the redo and the generating the animated GIF, it's like, yes, it should always be that simple, right? Whereas like normally it's a lot of work to write code that can do that type of thing.
Right, or it's horrifically inefficient, right? Because you're either doing these huge clones, or you have to do event sourcing yourself, right? You have to store these deltas yourself. It's a nightmare.
It's not fun. It ends up getting very, very manual. So stuff like Goya, like I honestly did not imagine that somebody would have done this so soon after releasing Om. This is the kind of thing where, like, I'm not sure if Om can solve like every problem that exists out there when you're doing apps like this, but certainly it's eye-opening of how it simplifies what you would think are hard problems.
Right, just by offering a different paradigm.
Exactly.
It's very interesting.
So you mentioned a while ago that you could get the benefits of immutable data structures and their equality by doing some more in-depth object observation. Do you want to talk more about that?
What I was going to say there is that works for like if you want to do fast rendering. So, a lot of libraries have come out since React that use the virtual DOM, but they actually end up doing diffing. They don't have the hooks that you need if you want to use immutable data structures. And it works great, and it ends up being pretty fast. But the thing that the observation method doesn't give you is this Goya style, it's trivial to travel backwards in time or forwards in time or snapshot every state. That stuff you're not really going to get from the observation. You'll still have to record deltas and, replay those deltas back.
And that snapshot stuff is more a feature of Om than ClojureScript or React specifically, right?
The snapshot feature is really comes straight from the immutable data structures, and we happen to provide them out of the box. I try to tell a lot of people the data structures that ClojureScript uses are basically ports of the ones that Rich Hickey, the inventor of Clojure, originally wrote in Java. We just ported them. They're amazingly well designed, and they're ridiculously fast. They're fast in the JVM. They're fast on modern JavaScript engines. A lot of the cool tricks we're doing, you guys could do too, as long as somebody said, I want to write a pure JavaScript version of these data structures that ClojureScript has. Really, the advantage of ClojureScript is that we've been working on these things for 3 years now, and we've been working on them 3 years, optimizing them from JavaScript engines based on algorithms that were optimized for 8 years by Rich Hickey, right?
Sure. So I'm a simple man. I'm bad at programming. I'm not very smart. When I look at
Lies.
Om, and I see how it's a great solution for some stateful UI problems, but my brain is just so used to constructing large web applications, kind of like what Merrick said, through these object-oriented frameworks where you construct these webs of nested stateful objects. And it seems like some of these frameworks handle some of the larger issues around building web applications, like URLs or kind of multiple different panes in your app at the same time or things like that. I don't understand how Om solves those problems. Does it just say those aren't the problems I care about solving? kind of on your own for that stuff, or does Om try and help you construct whole web applications? Does that question make sense?
It does make sense. So I actually think React is pretty awesome if you're coming from a traditional MVC thing. Like React's like amazing feature is that subview updating just works and it's not complicated. That's not really necessarily true unless you bring like a heavyweight framework into the picture. So React is able to deliver like a huge value just from the way that the diffing works. Like if I update some data up here in this view, all the subviews are going to update too. And that's pretty slick. So we get that. As far as some of the other things, other frameworks do give you they give you the M part of MVC, right? So if you look at Ember, if you look at Angular or Backbone, there's a really strong M story. And that actually, Om itself probably won't directly address that, but there are some things afoot. I think that even the M side, you could take an immutable approach and be able to do really, really cool things with that. But that's, I don't have anything to talk about today, but it's definitely something that we know is missing and is important that Om doesn't actually provide any real solution for.
Yeah, I guess a simpler way to say my question is it feels like React is a really good view layer and Om feels like it's a really good enhancement on top of a really good view layer. But that's not the whole problem that you're trying to solve when you're building web applications.
You're completely right. It's missing. I actually think that React is a pretty good C, like it's a pretty good controller as well. But no, as far as like, how do I represent my data? That needs work. There are some exciting things happening. Something I recommend looking at. Right now, it's a bit hard to understand if you're not like deep into the Clojure space. There's a project called JScript, which is by this Russian fellow. And he basically wanted to have something like Datomic, which is basically like, it's the database product that Cognitech makes. But what's cool about Datomic is that it has this really awesome data log query where it's like, you can basically have a database in memory in the client where it's kind of like a document database, it's kind of like a column database, it's kind of like a SQL database, but it's a lot more flexible. And I've done some prototyping with Om and JScript, and this seems like a really, really cool direction. And that would, I think, would like sort of like flesh out the whole story. Like, how do I store my data? How do I query my data? And how do I render that into a UI?
Sure. I guess one question I have is specifically around Mori and JScript. You mentioned that these things, Mori in particular has too big of a payload that you wouldn't feel comfortable sending it over the wire. So how is that different than compiling from ClojureScript and sending that over the wire?
Yeah, so the problem with JavaScript people that want to use ClojureScript is that they don't get to be a part of the compilation process, right? We rely heavily on the Google Clojure compiler to do whole program optimization. And this is something that like Uglify is pretty popular in the Node world and even in the front-end world. But if you generate code that Google compiler understands, it completely eats Uglify for breakfast. If I write a ClojureScript program and I go console log hello world, it's going to actually generate, after advanced compilation, the line hello world, right? So ClojureScript gets to go through that process. If you're a JavaScript consumer, you don't get to go through that process unless you're writing Clojure-compatible code, which honestly sucks. Like, that's the whole point of ClojureScript, is nobody wants to write JavaScript that's compatible with the Google Clojure compiler.
Right, because you have to do all the extern files and all those things yourself. It's a real nightmare.
Extern files, and like it's very verbose. You have to declare your namespaces. It's just not a fun way to program. That's something that ClojureScript handles for you completely.
The other question I had is, you mentioned, that Om kind of needs an M, so to speak, and that's kind of what your JavaScript is, but it seems to me that with a paradigm shift this big, maybe MVC is the wrong, pattern. Maybe there's something else. And I would be curious, does the functional world have an answer towards data to view kind of stuff?
That's a good point, because MVC came from Smalltalk, which is super object-oriented, right?
Yeah, it's also very popular for managing state and marshalling state. And since ClojureScript has different ways of state maintenance, or abstraction really, it seems like a different pattern would be in order.
I actually would disagree with that. So I started off with Om thinking like maybe we're just going to completely shake everything up. But the more I played with Om and the more I played around with React and started thinking about it, I even went back and like read all the original MVC stuff that came out of Smalltalk. And I actually think that the MVC conceptually is like makes sense. Like you have data, you need to present the data to the user, and you need to interact between whatever the user sees and whatever domain thing they want to manipulate, which is the model, right? That relationship, I think, is just correct. That seems to me a great model. My claim is that it's just the way that MVCs are implemented, that the fact they're built on mutability and observation of mutability, that I think we can get rid of and still get all the things that we like about MVC, which is a very good separation of concerns.
So you want to maintain MVC as a way to think about the roles of different pieces of a program, but not necessarily kind of the implementation of MVC we have today.
That's right.
Makes sense.
I want to talk a little bit about how Clojure is different from other Lisps or functional languages. I've been doing a bit with Scheme. I'll admit I'm fairly new to Scheme, but I've been playing with it, and I think it's a lot of fun. But when you say array, I think lists or tuples, depending on what's in them. And so I'm a little bit curious, you talked about how you have sort of the concept of like an object and things like that. I'm wondering how that is all managed in ClojureScript, where it seems like the core functionality in the functional programming that I've done to date anyway is based around lists, which can be loosely correlated with arrays as opposed to something as complicated as an object.
Right. So Clojure definitely broke tradition with definitely Scheme, and to some degree with even Common Lisp, and even like languages like Racket, which is a modern Lisp, which is really cool, in that JavaScript programmers, Python programmers, Ruby programmers, they want the right data structure for the job, right? You don't want in a list, a linked list might not have the performance characteristics that you want. You want a random access data structure. Mm-hmm. So Rich, when he designed Clojure, was like, everybody wants these data structures. We should offer very fast, very good immutable versions of the things that everybody likes. And this is something you hear from Clojure programmers a lot, is that people that come to Clojure are like, oh, I want to use a list. And people are like, well, don't you really want a vector? That's what you've been using everywhere else. And you know the performance characteristics of vectors. You actually don't want lists. In many ways, we embrace what other languages have embraced. The only thing we're getting rid of is mutability.
Got it.
Does that answer your question?
Yeah, it kind of sounds like a little bit more fully featured Lisp, so to speak.
Yeah, definitely.
It feels like it tries to meet you halfway if you have experience in more traditional object-oriented languages, at least with the data structures.
Yeah, for sure. I did skip the little bit you said about being able to do object-oriented stuff. And this is actually one of my favorite things about Clojure that's quite different from traditional Lisps, in that a lot of the classic lists that you would use weren't sort of built on an object-oriented foundation. So what that means is that when you get a list in Scheme, you can't provide a custom data type that looks and acts like a list, right? You're stuck with a concrete type. So the way that ClojureScript and Clojure is designed, if you want to create your own type and you want to magically work with all code that deals with lists, you can basically create a custom type that satisfies the list interface. And this is awesome because you might want to have a list that has some other methods or other behavior, and yet you want it to continue to work with some code that expects a list. And this is one of my favorite features about Clojure. By designing Clojure and ClojureScript this way, Clojure really feels like a programmable list in an even deeper way than just I got macros and I can do as much metaprogramming as I want.
Mm-hmm.
So can I take us in a little bit of a different direction?
Yeah.
We've talked a lot about ClojureScript, but I know for me I haven't done a ton, but I've played with it a little bit, and it felt like a pain to get started with. Is there a happy path for someone who's a JavaScript programmer who wants to mess around with ClojureScript? I felt like I had to install a lot of tooling and go through a lot of steps just to get my code running, basically.
It's without a doubt. ClojureScript is optimized for the Clojure community because that's easily the largest portion of our user base. We're starting to see more people get interested in it because of things like Om. But as far as being able to provide something that requires zero setup, for example, if you like Node, it's going to require bootstrapping, right? That's definitely a goal, like a version of ClojureScript that compiles directly to JavaScript, the same way that CoffeeScript or TypeScript does. It's something that we want to do, but it's not super high priority because there's not anybody in the community that's really pushing that process along.
Sure, that makes sense.
Well, we're excited about it. I mean, if we had it, it would be great, right? We would love that, to be able to just, fire it up and not install anything but Node.js. That would be awesome.
Sure.
I think I kind of gathered before you said something to that effect where, so the compilation, it compiles, maybe I missed this, and maybe I don't completely understand it, but so you're taking advantage of some of the things that Rich and some of these other folks have already figured out for Clojure. So the Clojure language, you're doing some of the work in Java and using some of the algorithms that they've built?
let me clarify. So ClojureScript is a Clojure program that takes Clojure source and generates JavaScript. So in order to use ClojureScript, you have to have a JVM. And then, of course, for it to be easy, you have to install, like, the Leiningen is the popular build tool. So Leiningen makes it really easy, like relatively easy to get started with ClojureScript. But if you want like a 5-minute setup, I have a tutorial. It's called ClojureScript 101. I have a blog post on this, I think, or it's that one, and I think it's called The Essence of ClojureScript. That's about as easy of a setup as exists. Light table is also pretty easy to do. It's pretty quick, but it's definitely something we need to work on. It could be a lot better for everybody, and certainly I think when we get to bootstrapping, it's going to be pretty awesome. It's something that's almost done. It's like this project that's so close to being done, but somebody needs to push it over the finish line. Hopefully it's something we can wrap up before the end of the year.
Cool.
Yeah, very nice.
That's really exciting. It sounds like such a little thing, but small barriers can cause a lot of, I guess, people to be turned away because we're lazy.
Oh, no. Yeah. If it takes 30 minutes to set something up and you're fighting, configuration, that's not a good experience. And that's...
Well, yeah, by the time you actually need to start addressing the syntax differences, if you've already spent your energy trying to get those jars in order.
Yeah, totally.
One question I have is, since you guys have this abstraction, right, this compile away, then run it through Clojure compiler, and you have these immutable data structures, it seems like you could implement abstractions for doing like maps and these kinds of things on web workers, a lot of these functional things. I'm wondering if you guys take advantage of any of that, or if you've just found the performance is not worth it.
So, I will say, like, concurrency is always a bummer to me. And, like, in ClojureScript, it's especially a bummer because concurrency is pretty fun in Clojure. You've got a lot of awesome things there, like you've got software transactional memory, and you've got, like, core async, which, like, gives you, like, Go-style concurrency. And we actually do have core async in ClojureScript, and it's pretty amazing. But things like web workers, we just can't make them work because you can't send data over a web worker, right? You can't actually move data structures.
Don't they have, the
post message stuff?
Well, you got to serialize with that, but I thought they had some way of transmuting memory blocks.
You have this thing called transferable, but it makes that data disappear from the side that sends it, and that will break everything.
Got it.
I wish they would just let us do it, because in the ClojureScript world, right, we can do that. We could send an immutable data structure into the web worker, and it would be awesome. And we would not be worried about these problems that everybody else is worried about. But because JavaScript embraced mutation and the implementers of workers are afraid of that, they make it really unsuitable for the types of things we would want to be able to do.
Sure. Well, that's unfortunate.
Yeah.
Seems like maybe River Trail.
River Trail would be cool. It's one of these things where I'm just like, if we could get enough JavaScript people to be like, look, if we use immutable data structures, we know this is safe. You should take off the training wheels on this.
Sure. When I talk to you and other people on this show, I realize that I probably need the training wheels, though.
So, David, you mentioned a few times, kind of hinted that there are things coming up in Om and in ClojureScript specifically. Is there anything, do you want to kind of lay out the roadmap for things that are coming soon? You don't have to announce stuff that's not announced or anything, but just kind of what do we have to look forward to?
I think probably the thing that I'm most excited about is working on the model problem. That's something I think needs quite a bit of work. There are some things about the way that Om works that needs fixing, I think. It's such a young library. Like, to me, the response for something that when I announced it was like 2 weeks old, pretty wild. Unexpected. I was actually blown away that people were so excited about it and that it created so much excitement about React. I was really surprising to me. I wasn't expecting that, actually. So to me, it feels like I just made this thing yesterday, so it doesn't feel finished to me. So there's like lots of small things that I need to work on. Nothing big as far as Om specifically. Definitely the model thing. I've been thinking a lot about the model part recently.
Sure.
That's super cool.
I have one question that might be a really dumb question, but it seems like there are certain things in the platform that you can't abstract state away, like DOM APIs. Is that why you kind of push for React so much? It's because it's an abstraction for the DOM, which is so stateful?
Right. So I would actually say that until React came out, I kind of thought ClojureScript was kind of cool, and it was like a cool idea. I myself wasn't convinced that it was good enough to like stop using JavaScript to do UI work. It was really React that said, oh, finally, these immutable data structures are really awesome because now we don't have to talk to the DOM and React can talk to the DOM, and then our data structures really get to shine. Right now, it's really valuable. Prior to that, it really felt like I would look at ClojureScript code and be like, it looks like you're writing some JavaScript in ClojureScript. I don't really see the big win here. I mean, some aspects of the program are simpler. Certainly, core async was pretty awesome. Like, I like the fact that core async tried to solve the complexity around asynchronicity and managing lots of requests and complex control flow around asynchronicity. But it really wasn't until React that I was like, okay, ClojureScript could be awesome for doing UI work when coupled with all these other things. Like, actually have a story that's like compelling, that's like, this seems a step up from what people were doing before.
Right, because otherwise people could just circumvent all the immutability story by just working through the DOM, right?
That's exactly right. You would look at typical ClojureScript programs and they just use jQuery and they they mutate the DOM. They're in many different ways. They're mutating handlers. They're adding event listers and removing them. I mean,
classic JavaScript plebeians right there.
It's not
I'm one of them.
It's actually not JavaScript plebeians. This is like, again, I like JavaScript and I'm still actually, funny enough, writing quite a bit of JavaScript right now. Still, the point is that why migrate from JavaScript if you end up just writing JavaScript in a different language? And you have to because the host and the environment really doesn't allow you to abstract it away. So React was like eye-opening, was like, it is possible to add a layer. And to me, what was impressive was that, JavaScript engines have come so far that adding this type of extraction is not actually a bottleneck.
Sure.
That's a good point. This probably would have been a different story 5 or 10 years ago before the explosion of competition in between browsers.
I think they would have tried and just wouldn't invest enough.
Right. I think that's true of most things that we're leveraging today, though.
It's true. That's true, too. Actually, it's funny, like our data structures 3 years ago, it was amazing. 3 years ago, V8 was the only one that was really like rocking. But now all of them are really like JavaScript Core, SpiderMonkey, V8. They're all really good.
Cool.
So I have to ask, do you foresee adoption of things like ClojureScript or even TypeScript or Dart or CoffeeScript that are a little bit closer to traditional JavaScript? Do you see the adoption level of those going up?
I think what you're going to see more important than whether people like really get excited about these different compiled to JavaScript languages is that I actually think that we're moving toward a time when people are finally getting serious about ES6 and people are realizing that ES6 will eventually land. You're starting to see more ES6 transpilers. You're seeing that people are getting really excited about generators. Like generators basically let JavaScript people do what we're doing with core async and ClojureScript. Generators plus promises are pretty awesome. And you can have those today if you're willing to use a transpiler. Then the transpilers generate source maps. So I actually think that in the future, it's really going to even JavaScript programmers are going to transpile. They might transpile JavaScript to JavaScript, but you're still going to see transpilation. So to me, the future is really just like JavaScript will be a compile target for everyone, not just people who are programming in different languages.
Yeah, for Angular 2, we're transpiling from ES6 to ES5 proper. So
yeah, I think everybody's kind of converging on the same thing. It's not as different as people seem, I think.
Yeah. Any other questions before we get to the picks?
I had one question. It's kind of related to what we've talked about already. You mentioned that most of the people who are using ClojureScript are part of the Clojure community. So they're already using Clojure on the server. They want to do stuff in the browser. Going back to JavaScript feels maybe unappealing to them after being in this world. Do you think there's a reason why it hasn't caught on as much with just regular old JavaScript programmers moving straight over to it? Is it just because of the paradigm difference between JavaScript and Clojure?
I think there's always going to be a little bit of, why should I use a different language? I mean, that's a huge barrier. I will say that I've been happy with the response to Om. I thought it was cool that, if you write a technical blog post and you have some real benchmarks and people can try them out and you have a really cool new idea about how you can do stuff, then people do listen, even if it's a different language. And I was actually pretty careful in my first Om blog post to focus on the approach and not the fact that, it was a ClojureScript thing. So I actually think that, we might see a few more JavaScript people try it out. It's really, for me, it's a non-goal. I'm not trying to, convince everybody that ClojureScript is the best thing in the world. I'm much more excited about talking about things like why React is awesome, why React plus immutable data structure is awesome. And definitely some of the benefits of at least some of the things that we have in our compiler and what we get out of that, I think is really cool. But if people like JavaScript, there are lots of awesome things happening in JavaScript. If you'd told me 5 years ago that ES6 was really going to happen, that JavaScript would have macros, that JavaScript programmers would be asking Lisp programmers about immutability. I don't think I would have imagined that this would have happened. So I think that the amount of interest from the JavaScript world, even if they're not actually using what we build, is great.
Cool. One last question from me. Does using ClojureScript and Clojure give you interoperability with like server code that isn't coupled to the server? I mean, Node, people kind of have that story. Like, what if I had my models in Node and the front end, right?
Yeah, it does. There's a tool called CLJX, which allows people to basically cross-compile. So you can have one source file, and it will automatically be shared on the server and the client.
That's cool.
Awesome. Let's go ahead and do some picks. Merrick, do you want to start us with picks?
Whoa, caught me off guard. I don't have any picks today, other than I think it's so rad that people think about things in such different lights. Like, my mind's totally been blown by this episode. It's just awesome. So, no picks for me today.
Yeah, I have to agree. I mean, going and doing some functional programming, like strictly functional in this way, yeah, it's kind of a mind bend.
I love that people have the courage to be like, maybe everyone's doing it wrong in this little thing, I think it's awesome. And then just continue to implement stuff. It's great.
Yep. All right, Jameson, what are your picks?
I just have one. It's a book on browser networking. It's called High Performance Browser Networking, surprisingly. It's by Ilya Grigorik. He's a Google engineer that has spoken and written and thought a lot about performance in the browser. And it's a fascinating read. I never thought that I would be able to read 100 pages about TCP/IP and not fall asleep, but I did it, and it's because the book is good. So it's good stuff.
We actually talked to Ilya on Ruby Rogues about HTTP 2.0.
Yeah, he has a section on it. I haven't gotten to it yet, so don't spoil it for me, Chuck.
I'll get a link put into the show notes for that.
Okay. That's my only pick.
Awesome. AJ, did I have you do picks?
No.
You were so quiet. I forgot you were there.
That was a mournful no.
Just having a bad day, I guess.
Do you have some picks?
I do have some picks. So, once upon a time, I picked The Host, the movie, which got a fantabulous 8% on Rotten Tomatoes by critics, but 50% by viewers, which means that it must be pretty good and critics just want things to explode more. The fight scenes weren't all that great. But the book, I read the book, and the book is definitely better. And I just like the story of The Host because I think it's just a cool idea of what it means to be human and like what it is that's part of our genetics and our bodies versus what it is that's part of our essence and our soul. And also I have some music picks. One is there's this original album. I don't think it actually goes to a game, but it's called Blue Dragon, and it's definitely video game style music. And there's also this, I think they're a Canadian-based band that I met when I was in San Francisco, and I bought some of their CDs and I stuffed them in a backpack or suitcase or something. I didn't find them until the other day, but they're also on Spotify, so I'll put in a link to them behind Sapphire. They're kind of like Muse meets Mraz meets Mumford & Sons. Like, they're not really like any of those things, but they're kind of a little bit like all of them.
I've got a couple of picks. I've been playing around with Redbooth. It's at redbooth.com. It's a task management system. I've been liking it so far. Just a way of managing all of my different to-dos. So I have projects for podcasts, and then I have a project like it's just a personal project and it's just tasks just for me. And then I set up a family organization for my wife and I, and so she can put the things in that she needs me to remember to do. Because if she tells me, I'll forget, and if she texts me, I'll forget. But if it's in this list, it's on my phone and I'll remember. Really digging that. Another pick that I have, and neither of these are really related to this show, but I've been reading Smart Money, Smart Kids by Dave Ramsey and Rachel Cruz, who's Dave Ramsey's daughter. And they talk about teaching your kids about money and finances and outline a whole bunch of things that you can do to help them learn how to manage money. And you can start them pretty young. There's pretty straightforward stuff that you can do. So I'm definitely going to pick that as well. And then I'll throw it over to David. David, what picks do you have?
I think I only have one pick today. I read this book last year. I don't know if people know, but Alan Kay writes on the internet. There's this really amazing mailing list called The Foundations of New Computing, which is actually publicly subscribable. And he recommended this really awesome book called The Dream Machine. And it's like the history of this man, Licklider, and like how basically he helped interactive computing come to be. And it was probably the most inspiring thing I'd read about sort of like the history of computers, but specifically interactive computing. And it kind of made me excited again about the type of work that, that everybody does around user interfaces. The Dream Machine.
You like sneakily picked foundations and new computing too. I was on that list for a while, and then I got intimidated by all the smart people, and then I unsubscribed.
Well, yeah. I mean, it got weird.
It was like too much for me.
Yeah, there was also a weird period there, but it was worth it just to be able to filter out Alan Kay's statements.
That's true.
Awesome. That sounds really cool. I'll have to go check it out. All right, let's go ahead and wrap up the show. Thanks for coming again, David.
Thank you for having me. It was a lot of fun.
This was great.
It's always fun to geek out over your favorite technologies, isn't it?
Yes.
Way to be a geek.
Mm-hmm. Hosting and bandwidth provided by the Blue Box Group. Check them out at bluebox.net. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more. Do you wish you could be part of the discussion on JavaScript Jabber? Do you have a burning question for one of our guests? Now you can join the action at our membership forum. You can sign up at javascriptjabber.com/jabber, and there you can join discussions with the regular panelists and our guests.